Dr. Chris saying he really enjoyed it and they asked really good questions. They being you, obviously.
Well, it was indeed great to have Dr. Chris with us.
Well,
it was indeed great to have Dr. Chris with us.
Okay, we are now live, so everybody looks smart. We are going to.
It was indeed great to have Dr. Chris with us.
Oh, great. Okay, we are now live. So
turn your volume down, otherwise we keep on hearing this ad infinitum.
Yes, I didn't realize it had loaded up. It automatically loads the YouTube stream when you start it.
Someone needs to turn the audio down.
I wasn't looking at that window. Aha! Here comes Precious. Rahana's screen looks frozen.
Okay, I'll move over to YouTube. Bye everyone. Enjoy the lecture. I'll see it from YouTube. I'll see you all tomorrow. Where is my YouTube? There.
Okay, Madam Chair, it is past, so you are welcome to kick things off. Perhaps, Precious, you want to introduce? I don't think Shegov Hatsa can hear me.
Welcome back, everyone. And welcome, Nwabisa, once again. And thank you for taking your time to come spend the afternoon with us. So this is one of our key talks where we get specialists in the field, in the science field, to come and address us. And today we are lucky to have Nwabisa Mkise. She is an Planeteer alumni, and we'll get to hear her share her journey and what she's been up to since she was among us as a Planeteer. Can we all unmute ourselves and give Nwabisa a round of applause? Over to you, Nwabisa.
Hi guys, thank you so much for welcoming me into the space. So my talk today will actually be on my master's research. I hope it's going to be visible and that my audio is going to be fine. I'm trying to connect it here. Just trying to connect my slides. I started with the wrong, oh wait, I want this one. Slide one. Can you guys see them?
Yes, looks good.
Okay. Okay, great, thank you. So my master's research was on detecting and mapping an alien invasive in the KZN commercial forest, and I was supervised by Dr. Ramon Lottering, and my co-supervisor was Dr. Kabir Piebe. Next. So in this presentation, I will sort of give you guys the background on commercial forestry and like make you guys understand what a commercial forest is. And then I'll go to the aims and objectives of my MSc and the study area that I chose to work on, the method I used, the results that I got, and then the conclusion. Okay, so you might ask yourself, what is a commercial forest? And a commercial forest sort of can be defined as a systemic planting of trees in a forest, and that like that forest usually is used for like production. So the difference between like a natural forest and a commercial forest is that like you actually have to physically plant a commercial forest and how it's structured, and that the trees in the commercial forest are usually used for something. So for mainly it's wood, timber, so on and so forth. But yeah, it doesn't, like, it can be endemic trees, like trees from that country in those forests, in the commercial forests, but sometimes it is trees from other countries, like exotic trees, but that are planted for the timber.
Nwabisa was, oh, and she's gone. Well, that's never happened before on our live stream. I know that she is on an internet network and on Wi-Fi and has her phone as a backup, so I think we should do that. I'm just going to tell her to do that. Everyone, you're just going to have to look pretty for those watching for a little bit while we sort that out. Anyone want to perform a song, whistle a little bit? I don't know. What can we do while we're on TV and nothing is happening? Kagadi, you can get the YouTube link by clicking on YouTube at the top. Let me just send you it. Apologies, everyone watching. We appear to have lost our speaker, as you can see. We will attempt to get them back as soon as possible. Okay, Nwabisa is swapping to her phone's internet. Hopefully that will solve it. She's confirmed she's on it. So we'll be back as soon as we can. We need some background music, I guess. Nwabisa, it'd be a great time for you to do your dancing.
No. It would be great to listen to Amapiano.
It would. It's really difficult with Zoom, however, to share anything like that because Zoom cancels it out. Peter is very good at it, and he's sadly not here right now. Yeah, I could put a YouTube video on of some Amapiano, I guess. Anyone want to wave to their mum so long? You know, you're live on TV. We're missing Aswara. Yeah, she's maybe having network issues again. It does seem that she struggles with the network, unfortunately. It is taking Nwabisa a long time. Nwabisa, come back. We need you now. There's at least 5 people watching. I don't know how long we can keep them. It's not the most engaging show so far.
Maybe somebody can be dancing in the meantime.
I said on Teresa, yeah, exactly. You know, he's told us that he's got this cultural dancing. What better to bring your talents to the front?
No.
She says she's working on it, coming back. Nwabisa is working on coming back. I don't think even sent the video, right? We haven't got it yet of the Boomwhacker video. That could be good to show.
Maybe Kathy should show us some exercises, CJ, just to feel us.
It's okay. Let's just wait.
What about you, Melissa? You suggested the dancing. I think then you should take on the responsibility. Once again, if anybody's just tuning in, we have some technical issues. We are working our best to solve them. We're hoping that Nwabisa has appeared just as I'm saying that. Nwabisa, well, you appear to have appeared. It's coming.
I'm so sorry.
Okay, I can hear you. That's a really good progress. We completely lost you. It was very jerky for a bit and then gone.
Sorry?
We basically completely lost you. Before that, we were struggling anyway. You can go right from your overview slide, I guess. You look to be concentrating frantically. I assume that's getting your slides back.
Still very bad. I just hope they can hear me. Yes, I just really hope you guys can hear me, because you still sounding like, you know, to me, when you're speaking to me, I can't.
I can hear you fine now. You can go from your overview slide. We didn't get anything from there.
Okay. Should I just do this one again?
Yeah,
okay.
Go ahead from there.
Okay, great. So sorry, guys, once again. Network, I'm home. So yes, so my outline of my presentation, that firstly, I'll give you guys a brief background on commercial forestry. I'll speak a little bit about India, even though I should have looked at it in an international sense, but I'm just going to focus on India, and then I'll go into South Africa. And then after that, I will tell you or will inform you guys of the aims and objectives of my study and the study area and the method that I used, the results that I received, and the conclusions and recommendations based on my study. So what is a commercial forest? So a commercial forest can be described as a systematic planting of trees in a forest which can be commercially exploited. And when they mean commercially exploited, they mean that you know, for example, timber, you harvest it for timber. Yeah, you use the wood for commercial purposes. And commercial forests can be from indigenous trees. So indigenous trees are trees that are found, naturally found in that country. So, but they can also be from like exotic trees from other countries that you plant in a commercial forest. They are naturally growing forests, and a commercial forest, obviously, like I said, it's systematically planted. So, doesn't, and like how it's structured as well. So, just forgive me. So the commercial forestry industry in India, you find that, okay, it's actually India is the 10th most richest country when it comes to commercial forestry in the world. And it's like commercial forests in India actually cover up to 22% of the actual land cover of India, which is quite a lot as compared to other countries. And it also contributes quite greatly to their GDP, like 1.7%. And like forest, like the forests in India are the people like plant them also for like other things, as like not just wood and fuel, which many other countries most countries just focus on wood and fuel, for example, South Africa. But India, like the forestry industry also sort of consists of like, India is known for its spices and things like that. But okay, here it's mainly saying that it's latex, gum, resin, essential oils, flavors, so on and so forth. So hence why it plays such a big role when it comes to commercial forestry. And then when it comes to commercial forestry in South Africa is also quite like a country that is very like greatly invested in commercial forestry, and that you find most of these forests along the coast from Cape Town, transversing to KZN actually has quite a large amount of commercial forestry, as well as Mpumalanga and Lebombo, and that is because of the weather conditions that are found in these provinces. For commercial forests to grow, there needs to be like a lot of rain, and it needs to be warm conditions because that helps them grow faster. So in terms of South Africa, commercial forests contribute about 2% to the GDP, and they are very important in terms of the fact that they also contribute, so they help in mitigating climate change because of the carbon sequestration. And if you guys have already gone through the plants and photosynthesis talk, you know how plants, absorb the carbon dioxide from the atmosphere and release oxygen, which we breathe. They also provide a lot of employment because you find that people from rural areas, they work in these forests, and they obviously also use the wood, so on and so forth. So, but the forestry industry actually provides a lot of employment in South Africa as a whole. And then you might ask yourself, so what is an invasive alien plant? As I spoke to you guys about exotic plants, and I spoke to you guys about indigenous plants, so on and so forth. So an alien invasive plant is, okay, the definition reads, a non-native to the ecosystem, and it causes economic and environmental harm, and may also affect human health. So the difference between an exotic plant to an alien invasive is that even though an exotic plant might not be from that country, but it does not cause harm to the other organisms in that space. With alien invasives, you find that when they get into like an ecosystem, they just take over. Like they cause other plants to, like they kind of cause an extinction of the other, well, death in that ecosystem specifically. They cause the other plants not to grow properly, and they just take over and they grow, and they like sort of like spread all over the place. And so that's the problem with alien invasives. And the alien invasive that I'm going to focus on is bugweed. And this alien invasive has been causing a lot of environmental damage to a lot of ecosystems in the country, but mainly commercial forests. And this alien invasive plant is actually categorized as the 6th most invasive plant in South Africa. There's 169 invasive alien plants that are recognized by the Department of Agriculture, Fisheries and Forestries, and bugweed is actually the top, like it's actually number 6 in the list. That's how invasive it is. It's actually quite high. And this is a picture of what bugweed looks like. I'm sure that you guys actually know it based on the picture. As you can see, like it's like those plants whenever you touch, and it actually causes like a skin rash when you touch it. I'm sure most of you guys have seen it because it also like grows in like in open areas around like homes, because I've always technically seen it since I was a kid. We used to play with it and so on and so forth. But yeah, this is what bugweed looks like. So the main aim of my research was to explore the use of 2 band texture combinations computed from a WorldView 2 imagery to map the presence of bugweed in that commercial forest. So GIS and remote sensing, there's different satellites, right? So the reason why I chose the WorldView 2 satellite is because it actually is like one of the most commonly used commercial forest satellites. So what remote sensing does is that it uses satellite imagery to sort of like view you know, attributes in the forest that exist there, hence why we use it to sort of map and detect the alien invasives. My first objective was to test an algorithm. So an algorithm, it kind of assists, like the algorithm is actually what you use to calculate like whatever you're trying to map. For example, myself, I'm trying to map an alien invasive. So what the algorithm that you use determines how well that attribute is actually depicted in the map that you are trying to make. So with myself, I was going to compare two algorithms that are known to be very good at mapping alien invasives. The first being the partial least squared discriminant analysis, the second being partial least squared linear discriminant analysis. So I was going to compare these two algorithms to see which one was better at finding, detecting the bugweed in the commercial forest. And then I was going to move on to texture combinations. So texture combinations, like image texture, is kind of like filters, if I were to explain it in simple words. You know, in filters, how we when we take a picture, we use different filters to enhance different things. So with texture combinations, that's what they do. So the two band texture combinations, I was using them because I wanted the alien invasive to sort of show more brightly in the picture, because that's what it does. Like, it helps to show it more brightly because it kind of like focuses on it when you're in the satellite image. And then obviously my last objective would be to create a distribution map so you can see in the commercial forest where this alien invasive plant is or can be found. So this is my study area. As you can see there, so it starts with an image of South Africa. So this is South Africa, and then in KwaZulu-Natal, that's where, like the small dot in KwaZulu-Natal, that's where it is actually close to Richmond. That's where the commercial forest is. And this is the structure of what the commercial forest looks like. As you can see, it's called the Sabi Hodgson Estate, the commercial forest. So this is a study flow of what I actually did in my study. So I got the image. Remember, I spoke to you guys about the satellite image, right? So I acquired the satellite image here. And then after that, I pre-processed it. And then on top of that, I went to the field to actually collect data. So what I did was I went to the study area. I actually went to places where there were presence of the alien invasives. And the reason why I did that was because of the fact that when I create the map of the detection of the alien invasive, I'm going to use my field collection to sort of like, sort of prove, like, yeah, like I want to, because of the fact that I know that by going to the field, I would have seen this is actually where it is. So when I use the method to map it, knowing where it actually is will help me to see how accurate my mapping actually is as compared to the real life presence of the alien invasive in the field. So then I went on to extract the texture. And remember, I spoke to you guys about the filters. I used the different filters, so that's what I did there. And then I compared the two algorithms that I spoke to you guys about. And then I started checking the accuracy, which one is more accurate. And then I found out that actually this one, the PSLDA is more accurate, but I'll explain that more when I get to the results. And then I continued to then use the PLS-LDA and then continued to filter it down using texture combinations to then get to a point where I'm creating the bugweed map, which is right here, which is literally the main purpose of the study. So these are the results of when I was comparing the two algorithms that I spoke to you guys about. As you can see here is that the PLS LDA, I only got like a 60% accuracy. So I was only detecting it 60% accurately with the PASL LDA. And then with the PLSDA, they are very similar, hence the confusion. I actually got a 67% accuracy. So that then showed that actually the partial least squared discriminant analysis was detecting this bugweed or this alien invasive better than the partial least square linear discriminant analysis. Hence, when I then continued to, like remember I spoke about filters, when I continued to filter, I then only used PLS LDA. And then in doing so, what happens that with the satellite image, right, it has different bands, spectral bands. Like I really don't know how to sort of simplify that and make you guys understand, but the image has different bands. And in having those different bands, I wanted to see that which band actually produced the highest accuracy. And as you can see here, it's the near infrared 2 band that produced the highest accuracy, and the other ones didn't do so great. And on top of that, I looked at moving windows, right? So with moving windows, it's more like, oh my goodness, it's like special scale. So it's like the pixel, yes, great, I know. So you know the pixels, you know when you say 10 megapixels, right? That means obviously that picture is better than the 5 megapixels, right? What I found in mine was that the 5 by 5 mega sort of like moving windows, which are the megapixels of the image, actually gave me the better results as compared to the 3 by 3. The 3 by 3 were too small, you know. They didn't like get all like, because what happens is sometimes the bugweed, it grows in like a big, like in large groups. So with the 3 by 3, it was too small. It wasn't getting all of them because it just kept it divided like into just very, very small pixels, and it didn't really like map them correctly. And the 7 by 7 as well, it was just too big. It was not like it was getting like some of the actual forest and saying it's an alien invasive when it actually really isn't. Yet the 5 by 5 was the one that actually gave me like the best results, and it kind of got, yeah, the best results. So these are the texture combinations. Remember, I spoke to you guys about the filters. So these are the filters that I used. And as you can see, okay, I'm not sure I can explain it, but it was just the best filter or the best texture ratio that actually gave me the best results was correlation over variance. It's going to be very difficult to explain that. I don't know how to simplify it, but it was the 5 by 5 moving window. Remember, I spoke to you guys, and the 7, that near infrared band that I spoke to you guys about, combined with the correlation over variance. So then, using all of these things, I produced a map showing where the bugweed is, as you can see here. So remember my study area when I showed you guys when it was empty and it was white. So now you see in this is the final product that I produced, and you can see wherever you see this red color, that's where you are finding the bugweed. And as you can see here, it's obvious, like it's usually like it's in trenches, it's in open areas, it's like you can find it even near the edges, because usually that's where most alien invasive plants grow. But yeah, so I definitely managed to map it out, as you can see here. I think this is a cool map. I don't know if you guys agree, but yeah. And yeah, in terms of my results, obviously we concluded that the partial least square discriminant analysis outperformed the partial least square linear discriminant analysis, because remember, PLS LDA got a 67%, whilst PLS LDA got 60%, while PLS LDA got 67%, which then meant it was better to use, hence why we then used it. We also found that when we use the 2 band texture combinations, remember when I spoke about filters, when we use this type of filter, it improved the accuracy by 8%, because then it went from 67 all the way up to 75%, which was the final percentage. And I spoke to you guys about the 5 by 5 moving window, the different megapixels, and that it was also the best one. And also the texture ratio that was the best to map the bugweed was correlation over variance. And the awesome thing about my study is the fact that it was the first study that has actually accurately mapped bugweed with a 75% accuracy in the Sappi-Hodgkinson commercial forest. So no study has actually ever used these texture texture combinations and this algorithm specifically to map bugweed, and I was the first one to do it, which was awesome and great, and I did so with a 75% accuracy, and yeah, I'm very happy about that. And in terms of recommendations, like, because as a researcher, you have to recommend what you could have done more, like what could actually increase your results, because 75% is a great result, but you know, I can increase it to an 80, I can increase it to a 90. And for me to achieve that, I would try using like the 3:3 texture ratios. Like that's like using a different filter. I tried to maybe experiment with other filters to see, use a different satellite image. Yeah, this one I'm actually saying that we must use the star image because it also has, you know, good ways of depicting alien invasives, as well as use multi-temporal data. So those are the study's recommendations as to how one could improve the results of the study. I hope you guys understood me. I know there's a lot of technical stuff. I honestly tried to explain it as much as possible for you guys to understand. But yeah, those are the nitty-gritties of my study. And thank you. Questions?
Thank you, Nwabisa. Can we just unmute our mics and give her a round of applause? This was indeed an interesting study. Do we have, who will be the first one to ask a question? Kimberly, I see your hand.
Yeah, so my question is, do you feel like if you collected more field data that it may also help with improving the accuracy by detecting where the species were?
Definitely. The more field data you collect, the better results that you receive. But the thing is that being that it was a master's project, you get a specific time limit, you know, to finish the research. So for my study, that's all I could do. But definitely, if I had more time to collect more field data, I definitely would have had a higher accuracy, maybe even an 80, maybe even a 90%. It would have definitely contributed greatly towards getting a better results. Thank you for that question.
Thank you.
Any other question? Carl?
Hi, thanks, Nwabisa. That was a really interesting key lecture. I enjoyed learning a bit about satellites being used terrestrially, as mostly I see them being used in the oceans. I was wondering if you know anything, or you can say anything about what causes the error in your measurements, right? So 75%, that means 1 out of 4 times your measurements fail to detect the buckwheat, right? So 3 out of 4 times it gets it right. 1 out of 4 times it gets it wrong. Is there anything that connects those 1 out of 4 times? Like, is it when it's on a slope, or is it just random, or you don't know?
Well, I think being the fact that it's a forest, so what, like sometimes the length of the trees, like you find that other trees were still like sort of short, like the forest trees were still short. So then they were then sort of categorized as the bugweed, because bugweed is like a little bit shorter as compared to the forest trees. So the how tall the tree is at the time, and yes, definitely if it's in what technically it kind of helps for it to be in like trenches, because then it kind of like it detects it better when it's in trenches, because of the fact that, you know, it's like one of those you know, what variables I inputted in my program to sort of like, because I know that lots of bugweed grows in trenches, so I inputted it as one of the things to look out for. So yeah, I'm not sure if I responded correctly.
Thank you, Nwabisa. Siteho, you have a question?
Hi, Nwabisa. Well, thank you very much for your presentation. It was indeed a lovely presentation. I don't have a question necessarily on the content, but I I want to ask, in terms of challenges, what kind of challenges did you encounter during your research, and how did you overcome them?
Whew, that is a great question. Definitely a lot of challenges. Firstly, it was meeting deadlines. I won't even lie. It was like super hard to meet deadlines sometimes, and getting feedback on time. And then secondly, it was because of the fact that I was dealing with satellite data and all of that, I needed like lots of storage space. So that meant I had to purchase like a hard drive, and like just I had to get like to work with equipment that allowed for such a large like amount of data to be handled. But thankfully, the UKZN obviously provided most of the things that I needed, and yeah, and it was just time. It was just sometimes focus, because we changed a lot of things here and there, and whilst you're conducting your study, something new comes out, and you then have to now incorporate it, or have to now think about, could this actually mean it would make my study better? So then you just have to decide which one you are using, and you're going to stick to it throughout, and then you obviously finish in as quickly as you can before other people, because with the research, it's other people you can be doing your research, and then other people can somewhere else could be doing it, and whilst you doing it, they get the results, and then now yours is kind of like yeah. I'm done. Thanks.
Any other question? I have a question, Nwabisa. First of all, I really enjoyed your talk, and it was quite interesting for me to see that satellite are actually used in terrestrial studies as well. But I also know that they have a lot of faults, especially in studies done in the ocean. So I wanted to find out if you had like similar challenges, like cloud cover and not being able to get data for other parts of your study region. And my second question is why bugweed? Why did you focus mainly on bugweed? Is it because it's the most common invasive plant, or is it because it's the most damaging to the commercial forest? That's my two questions.
Uh-oh. I think she's gone again.
Okay, the first question was, I definitely did. I'm back. Am I?
You're good. Sorry, my bad.
I'm here. Yeah, my network is bad though, but I'm still here. So the first question is, definitely I did encounter like I had to, well, we had to sort of ask for different dates to find which one was actually taken on like a cloudless day, because cloud cover definitely affects the ability of the image to detect the alien invasive. But also the pre-processing, remember when I was telling you guys my study flow, the pre-processing helps, because any of those, like if it was like maybe parts of it was covered by clouds, there are processes that you can do to sort of try to remove those areas in the image, so that it helps when you are detecting, to detect better results. So that's how I sort of tried to work with that. And in terms of why did I choose bugweed, it's because of the fact that in KwaZulu-Natal, it's one of the most invasive plants that you find in commercial forests. That's why I chose it. But truthfully, it honestly isn't like research on bugweed is not like vastly done. I know quite a few. I mean, it's been done, definitely, it's been done, but not a lot of people, currently are working on it, and hence why I chose it, because even though it's like it's so, you find it occurring often, not a lot of people still are focusing on it. So I tried to focus on it. Yeah.
Thank you, Nwabisa. Any question?
Thank you.
Lebo?
Hello, Nwabisa, how are you? Well, I've got like two questions. The first question is, Okay, your presentation was quite interesting to start with. So my question is, what really pushed you to such an extent that you make such a study? That's the first question that I would like to ask. Number two, with regards to the type of field that you entered into, what kind of jobs do you guys focus on? Highlight me on that. Thank you.
To be honest, the reason why I kind of found myself in forestry, I've always been really interested in forestry. I also got an opportunity to attend the International Forestry Conference in 2015. So that kind of like made my love for forest, grow. Even though I'm more interested in like natural forest and indigenous forest, but my supervisors also sort of advised me because of the fact that they work with commercial forestry and that there was a need to map alien invasives in commercial forestry. So because I wanted my study to have like a use, I wanted my results to be used somewhere because I don't want to just conduct a study and then it's just I wanted it to have to assist somewhere. I then decided to do a study in commercial forestry because I know that with these results, I can, send them back to, people who are working with the forestry industry and they can, help, use it to better control the alien invasive in their area. And my degree is geography and environmental management or environmental sciences. I focused on GIS and remote sensing. So the job that I can do with GIS and remote sensing, you can be a GIS, technician. But I also, focused on environmental management. So with environmental management, you can be an environmental officer. Yeah, those kinds of jobs. And, you can do EIAs and, EMPs, that kind of stuff. So environmental management, I mean, I can even go into waste management because it's still part of environmental management. Environmental management is broad, but the focus that I focused on, obviously, for my MSc and honors is GIS, which is mainly GIS technician, GIS work there. Thank you.
All right, thank you, Nwabisa.
Ondireti.
Hi, Nwabisa. I wanted to ask you that when you were forming the PLSDA and the PLSLDA, did you use any physical traits of the plant for you to locate it?
Yes, I definitely did. Because like, remember I was speaking to Dr. Cole as to what assisted in the percentage of my accuracy is that I know, obviously when I went to the field, I could see that the alien invasive itself is obviously shorter than the commercial forest. So when I was programming the PLS LDA to sort of find it in the image, I did sort of like input that it must try to find trees that are within this height, that are the structure of the leaves as well was different. The commercial tree structure as well as the invasive tree structure, the leaves were different. So I said, obviously, because what you're doing to the image that you sort of input data and say, this is what you must look for. So that's what you do. So I definitely did incorporate height, the structure, what else? The coarseness of the leaves, because that's the great thing with image textures, that even the coarseness, because the other leaves were smoother, and with the alien invasive, the leaves were actually more coarse. I could input that, and then it helped to give such a high percentage of accuracy when it was detecting.
So what I wanted to ask you is it true that getting a hold of these types of data sets can be expensive, or was it like freely available for you?
Nwabisa, did you get the question?
Thank you for the question. Yes, definitely, especially with worldview, because it's a commercial sense. Yes, I got the question. So the satellite imagery is very expensive. There's actually free satellite images though, ones you can find for free, ones that are actually somewhat affordable. But the one that I used is very expensive, being that it's a commercial sensor, like usually like SAPI, Mondi, all of them, they use that one because they can afford to use it, obviously, but it is pretty expensive. But for my study, I got it from my supervisor. Like I mentioned that he works for SAPI and for Mondi, so I didn't have to purchase it. Yeah, but I was heavily what's this, not just like, what is this, like lots of my examiners technically did say, like, you should have used an affordable sensor, or you should have used a free sensor, being that I was a student and so on and so forth, so that people who want to replicate my data or improve it, or they could, but then yeah. Thank you.
Okay, thank you.
Hadi.
Okay. Thanks for the lovely speech. I wanted to know what is it that you personally discovered that you think is very special about your research? Like what was your, like, the only thing that excited you the most that you discovered through the.
Well, I think the one thing that excited me the most was the fact that I was the first person. Well, I'm still planning on publishing, but like the fact that no one has actually used the two band texture combinations to map the spugweed. So the fact that I am doing a study that technically hasn't really been done before, that was exciting to know that I'm contributing to research and I'm doing this new thing. And I'm hoping that by doing it, it's going to inspire other people to use this. Remember, I was speaking about the filters, right? So to use these texture combinations in their studies to help improve their classification accuracies as well.
Thank you, Nwabisa. Do we have another question?
Mulisa.
Well, hey, Nwabisa, your research was very wonderful. Thank you so much for sharing the information. I don't really have a question.
Okay, seems like that's the last of our questions and comments. Can we all unmute ourselves and just to say thank you to Nwabisa for joining us this afternoon.